Weston is saying, okay, and my code I know is Weston. It's such a, yeah, wow, I never would have guessed that. This is so secure. And because of that, that's actually why I have been using the VPN like last night in my room, just when I'm doing my personal email. Trying to connect, let's see. This light is really something.
So I moved at a table once. I'm trying to figure if there's a place that's good for me. It kind of does. You kind of look at the lights.
Or you could take, whatever. If you're too far away, I'm not going to probably think to look for you.
Sit over there.
Okay. That sounds good. Okay.
Although that then puts me away from the microphone.
Yes, I can see everybody, even without my glasses, except the back couple of tables. If I didn't know who was sitting there, I wouldn't know who was sitting there. If somebody's raising their hand there, I might or might not notice it. So having the roaming people, I mean, this won't have questions, but in general, yeah.
Oh yeah, that was. Are we not doing front parts?
For,
All right, folks, it is 11:06. Let's go ahead and take our seats, please, and so we can get ready to start our next topic.
Did Ben just... Usually there's like a bell or something. I asked about that.
All right, welcome back. Thank you for accommodating our schedule and drinking your coffee a little more quickly. The next thing we're going to do today is review or have a review provided for us of the position papers that were submitted in advance of the meeting. And to do that, we thank Ruth Marnshaw from Stanford University.
of course, I have to log into my computer again because of security. It has already put the screensaver on. Those 2 minutes where you too could have read my notes. Okay, thank you for the opportunity to give you very, 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 very brief overviews of the 13 papers that were submitted. I have it on good authority that everyone in this room can read. So I am going to count on you to, if you haven't already, tonight or tomorrow when you have nothing to do, you're waiting for your plane, or tonight after the dinner, go back and read at least the papers whose topics or what you hear from me or from your colleagues here piqued your interest. The 13 papers represented 11 institutions. We had 2 papers each from Johns Hopkins and Chicago. And again, my goal is just to give you a brief snippet about what these papers were about. So several of the papers were position papers more, but most were really experience papers, and I think that's wonderful because you can learn, we can all learn from each other. A number of the papers described research data management solutions that have been developed to meet specific needs of specific research communities, science projects, or collaborations. but some of them actually can be extended beyond the original community that it was designed for. In general, these were not top-down research data management mandates from the VPR or, oh no, the NSF says we must share data, let's go spin up something big. So the first set of papers that I'll describe to you were really research, project, or collaboration focused. Kia Huffman and colleagues in the Department of Ecology and Evolutionary Biology at Brown University developed a research portal called the XMA portal to enable data management and data sharing for a specific research area. And that research area is motion analysis research. All right. Brown University offers central file storage and other institutional repository tools, but those tools, while useful, didn't meet the data management and data sharing needs for this specific research community. And so back in 2009, so this is not a new initiative, this research community started developing its own solution. One of the things that they noticed from existing solutions at that time at the institution was there wasn't a good way for end users to attach metadata and to view data plus metadata together easily. And they also were concerned about the extent to which some of their institutional solutions could accommodate the large data sizes that their community's collection of tools required. It really became a one-stop shopping place for data and metadata management with data sharing, and that's really important because they're sharing their data not just within the community at Brown, but actually to other institutions and communities. So that seems to have been a very successful and long-standing data management initiative. Like the XMA portal, Johns Hopkins/Maryland Advanced Research Computing Center's CRADLE framework was use case driven. CRADLE stands for the Collaborative Research Administration Environment and Data Library. Whew, glad they call it CRADLE. And like the XMA portal, there was a need that spanned for data management and data sharing that really spanned institutions and projects. This is described in a paper submitted by Adam Sierakowski, and I believe he is here today. He was registered, I hope he's here. And this tool and this environment developed around supporting the Hopkins Extreme Materials Institute. They coordinate activities for their community across hundreds of researchers who need to share large data sets, and they wanted really to catalyze, not just store data and share data, but catalyze collaboration through data discovery. CRADLE, they believe, can be extended beyond their community. It's built from building blocks that aren't specific to their domain in any way, shape, or form. But what I really liked about CRADLE that was different from some of the others is they actually incorporate research administration and research administrative data management as well, tracking your grants and your projects and publications, not just the data. They have automated data population, and one of their goals is to make data management, per some of the comments we heard just a few minutes ago, really part of the researcher's daily workflow. This is just how they get their work done. Another effort that is underway that's focused on a specific research community is Columbia University's Zuckerman Mind Brain Behavior Institute with a paper from Raj Bose and his colleague called Research Data Storage for Columbia's Zuckerman Mind Brain Behavior Institute. And they talked about the evolution of their strategy and their approach to coming up with data management solutions for the researchers in their institute. This is a fairly new institute at Columbia, and they really approached this from a starting point of engaging the researchers, a lot of interviews and discussions with the researchers to actually understand what they did, what their workflow was, and then come up with solutions for that. They're really focused at this point much more around data management solutions for your working data, not so much archiving and publication management, but that will no doubt come in time. And then yet another really excellent experience paper came from, this is a mouthful, the University of Minnesota's College of Food, Agriculture, Natural Resources, and the Minnesota Supercomputing Institute. A very large collection of authors. The lead is Graham Allen. I'm not sure if Graham is here, but Jim Wilgenbush is here from that team. And the paper is GEMS, an innovative agroinformatics data discovery and analysis platform. And so GEMS is pulling together data sets of different types. We heard earlier about some of the challenges of data from experiments, data from this source, that source. They're looking at genetic, environmental, management, and socioeconomic data to provide multi-scale analyses. This is another example of a research data management solution and a framework that is intended to span research institutions. The GEMS community actually is international. And they've combined, per some of the comments from the last panel, domain expertise in the science with their HPC teams and their bioinformatics specialists to really craft a very nice environment that will be going live soon. One of the things I most appreciated about their paper was that they pointed out what they saw or see as a key element to success of an RDMI platform, and that you have to have the right data. It has to be at the right time for that community, and you have to have the right technologies. All of these have to come together at the right time. 20 years ago, they couldn't have done, 5 years ago, what they've done today. It was also a good example of how, while they've built a custom platform, they've really done that with sort of commodity, industry standard in our industry, right, building blocks around security, curation, federation, authentication, using Globus in common. If you look at the table in their paper, it gives very good detail on that. And then at UCSD in San Diego Supercomputing Center, and I'm not sure if anybody from those institutions is here, Amit Chareja and some of his colleagues are on the second iteration of a platform they developed, and that's called SeedMe. It's a data sharing platform. And it came out of not a specific need within a specific science community, but across the science communities they supported, they were getting the same request over and over for visualizations, little websites, how do I share my viz, how do I share the data underneath it. So they developed a platform for that. It's been in use for 3 years. It has more than 600 users and 140,000 different content items across many disciplines. They are starting on SeedMe 2. The paper has a reference to a URL that you can go take a look at a mock-up of what SeedMe 2 will look like. And SeedMe 2 extends SeedMe, but in ways that were specifically requested by the user community. And that's an important element, that it's not just us HPC people and the librarians deciding what tools need to be there and what capabilities, but to engage the communities. There were also several papers that talked about evolving needs beyond what SeedMe has done, dealing with data at scale and dealing with data, the wealth of data across an institution. Preston, whom you just heard on the panel, and Carol Song from Purdue have developed a number of solutions at their institution, and I'm not going to talk about those because Preston just did. And the paper's available and his slides will be available as well. University of Chicago, also referenced by Dr. DePablo in his presentation, also has a number of institution-wide data storage and data sharing, data management solutions. The paper from our organizer, Barali, focuses specifically on DALI, the data lifecycle instrument for managing and sharing data. Again, it cuts across disciplines. It came out of the research computing team at Chicago, but similar to what Minnesota has done, the building blocks and components are all sort of standard. They did take the XDM data management platform that was in Kia Huffman's paper that I opened with, and developed an XDM data management interface for that. But in general, most of their building blocks are just that. They're building blocks. They're tools you could take at your institution to do something similar. And a third paper that relates well, experiences with data at scale, is from, if I can page up here, David Fearon and the Johns Hopkins University Libraries. They talk about addressing the gaps in data archiving for large-scale computing research. Again, no surprise, there's a lot of data now. There's even more data than ever before, and while the library at Hopkins and their data management group is in its 7th year of operation, and they have an archive solution and a publishing solution. They really are re-architecting what they're doing, and the paper goes into detail on that, to try to address the need for large data files, large-scale data ingest and sharing. And it was nice. It's not just that they recognized this need, but they tried not to just fit it into what they were doing. They're re-architecting their solution, and again, with common tools. That paper also talks about the importance of partnership across the institution, and it links back to the earlier paper that I referenced from Andrew. There's really a lot of good information in that. Now, some of the solutions that we just described were lab-based, some are research computing center-based, some library, all involve some degree of partnerships outside an immediate research project. But there was a paper that looked at, really, to some of the comments earlier today, how should research data management be organized at an institution, or how could it be? We heard about, well, you got the HPC group, the library group, the researchers. Do we talk to each other? Do we even use the same language? And Jamie Wittenberg from Indiana University Library, Scholarly Communication Department, wrote a paper about RDM in context, embedding data in open scholarship at IU. And so the data management program at IU within the library began in 2011, so it's been around a while. But at the same time they stood that up, their university IT research technologies group was standing up RDM services, and the VP for research was also engaging in RDM. So the IU libraries now are working on a research data service, RDS, to formalize those currently informal partnerships and collaborations across these different groups that support RDM. And actually, they're going to embed this in their scholarly communication services and open scholarship more broadly, so cast it within that. They have a fabulous repository today, but they're looking at ways to grow that, integrate research data publishing into their current open journal system platform, and they incorporate scientific specimens as well, especially 3D digital data, which was kind of interesting. IU is one. This came out of one particular campus, but IU is a statewide system like many of yours, and to a point made earlier by one of the presenters, they're starting to talk about, and they've actually agreed upon, having a shared Fedora repository across all of the IU system campuses. So that's pretty exciting. So mostly what we've heard so far are about solutions or problems and solutions from academic institutions. There was also a paper from Anita DeWard of Elsevier titled The Mendeley Data Management Platform, Research Data Management from a Publisher's Perspective. And Elsevier shares, I think, the common goal that we all do. You want to make data accessible, discoverable, and reusable, not just deliver content, but actually have solutions. One thing highlighted in the paper was a need for incentives for data sharing, such as credit for shared data, and tools, to a point made earlier again. How do you know that data are being shared? What are the metrics? Do they matter? How do we go about this? And some of you, especially from the library community and publishing communities, are involved in this on a daily basis. I'm not, so this was really new and interesting to me. The state of the practice really is that it's hard to tell how much data is shared. If you download data, does that mean anybody ever used it? They actually went and looked at acknowledgement sections in articles, and they surveyed 1,200 people across the academic community on their data sharing practices. Some of what they discovered probably isn't a surprise to you. Lack of standards regarding how data are cited in journal articles makes it difficult to assess how widely it's used. In their interviews, too, with these 1,200 individuals, what they concluded was the main barriers to data sharing today were really privacy concerns, ethical issues and IP rights, and lack of training. We've heard a lot in the last panel about how important training is. it really, what they found was that mandates from publishers at that time and funders were not seen by researchers, no surprise, as a driving force for research data management. And the real gap between desire and practice of data sharing standards. And the paper goes on to describe Elsevier's tool suite for data management, this Mendeley data management suite that, again, probably many of you in the audience are familiar with. I wasn't. So as we think about RDM and RDM implementations, we need to spend some time thinking about what are the problems we're actually trying to solve, because there are many. Andrew Johnson from the University of Colorado Boulder's Center for Research Data and Digital Scholarship suggests that we take an outcomes-based approach to RDM when we think about that, and indeed, that is the title of his paper, Toward an Outcomes-Based Approach to RDM, Experiences from Their Group. And he makes the point, which is, it's like when you read, it's like, well, duh, but we forget it sometimes, that RDM processes and the solutions are going to vary depending on what your desired outcome is. What problem are you trying to solve with your research data management solution? Probably there is no one size fits all. He gives the example of IRBs, and at least at his campus, in the IRBs section on data management, the focus is really on data security. So if a researcher comes to you and needs help with RDM to ensure data security, what he would stand up at his institution, what they have, is going to be different than what they might propose in the context of a data management section of an NSF grant, where they are, not that they're not concerned, about security, but they tend to focus, at least at his campus, in their descriptions on data sharing. And there are different infrastructure and different expertise needed. If your outcome, what you're trying to achieve is data reuse, but you don't have a careful eye towards reproducibility, then the solution you come up with, or solutions, may and probably will vary. Okay, and then Rachana Ananthakrishnan and colleagues from University of Chicago in Argonne, in their paper, which is Design Patterns for Data-Driven Research Acceleration, they actually suggest that we stop and get out of the weeds of, are we using Globus, are we using Fedora, are we doing this, and think about the bigger picture, and can we extract some specific design patterns for what we're trying to accomplish, especially as they think about data-driven discovery, and say, there are two main things, and we can already solve those problems. One of the needs that they identify is for high-performance, secure delivery of large amounts of data. And he said, we've got solutions for that already. Modern research data portals that are scalable and performant. There are lots of examples. And the other is instant and automated data sharing, especially off instruments. And they propose and identify some certain tools that exist already. And finally, in my last minute, the last paper, Jim Myers from University of Michigan, also the National Data Service Consortium, and I don't know if it's SEAD or SEAD, S-E-A-D, okay, SEAD, provides what I read. I mean, it's a fabulous paper, and I've read it 5 times now, and each time I read it, I get a little something else out of it, and I believe Jim is here, you can talk to him, but I read it as a call to action, all right, for the community. It's titled, Where's My Universal Data Browser? And he does a wonderful job of differentiating between real infrastructure that today can solve real problems, and essentially aspirational infrastructure that we'd all like to have in this magic world, but have dependencies on so many other things happening. But one of his points is, similar to what we saw in some of the other implementations, there are a lot of tools and capabilities out there right now. Sure, we need standards around a lot of things, but there is a way that with not much effort, we could deliver upon request data publication to research projects. I encourage you, again, to go back and read all of the papers. Again, with, I think, one exception, at least one of the authors or co-authors from every paper is represented here at the conference. So I encourage you to read the papers and talk to these folks and see what insights you can share with them and what more you can glean.
Thank you, Ruth. And I actually would like to do another round of gratitude applause for all those who took the time to submit a paper, because that is extremely useful to the goals of this conference. Okay, so as we warned, next on the docket is to do some small table discussions. So hopefully you are all sitting at the table that was assigned to you for breakout session number 1. If you are not, please go to your assigned table. We've tried to mix and match people purposefully for hopefully a fruitful discussion here. So there should be a slide coming up on the large screen that is very similar to the ones that are at the center of your table, except for the fact that it has a URL to a shared Google Drive. And in there are 3 documents, one for each breakout session. So please, with the scribes for each session, feel free to scribe however you want to. Ultimately, we would like notes from each table added to this document. There is a section in each document for each table. Just follow your table numbers. You can do it live. We should hopefully not crash Google by having 11 people in that document at the same time. Take your notes there and be prepared to wrap up in 2 minutes. So what we're going to do is split this in half. We're going to take the first 30 minutes of the hour to have your table discussions, and then we are going to have one person from each table come up and take 2.5 minutes, exactly, to summarize what was discussed at your table. So there's 3 questions for you, and what am I missing? What am I wrong here? Breakout session. Okay, the reports will be after. My apologies. We're going to do the full. You get to talk for an hour. My apologies. Thank you, Barali. But the breakouts, the reporting back still will be constrained time-wise to a half hour. So I will give you some warnings at 20 minutes, at 40 minutes, and when we're approaching the final hour, just to keep each table in scope for knowing that you have time to address all 3 questions. As usual, if you have any questions or concerns, please don't hesitate to reach out and let us know what we can do to help. And Barali, we also have at each table a discussion facilitator, is that correct? Yes, okay. If you don't know who is the discussion facilitator at your table, please let us know.
We all did this time.